Which expression is larger, square root of 10 plus the square root of 14 or square root of 11 plus the square root of 13? We can see that the first expression has the larger square root of 14 term compared to the square root of 13 in the second expression, but also has the smaller square root of 10 term compared to the square root of 11 in the second expression. So which one is bigger overall? It's hard to tell just by looking, but there's a technique that we can use to compare these kinds of square root expressions. So we'll let a equal square root of 10 plus the square root of 14, and b equal the square root of 11 plus the square root of 13. So a and b are the two expressions that we are comparing, and what we'll do is square both expressions. So a squared is equal to the square root of 10 plus the square root of 14, all squared. And that just equals 10 plus 14 plus 2 times the square root of 10 times the square root of 14. And that simplifies to 24 plus 2 square root of 140. So b squared is equal to the square root of 11 plus the square root of 13 all squared. And that just equals 11 plus 13 plus 2 times the square root of 11 times the square root of 13. And that simplifies to 24 plus 2 square root of 143. So what's great about this is that both a squared and b squared have the same integer part. Both expressions have 24 as the integer part, and they also have 2 times the square root as part of the sum. But we can clearly see that square root of 143 is greater than square root of 140. So this implies that 24 plus 2 square root of 143 is greater than 24 plus 2 square root of 140. And this makes sense because both expressions are the same except for the different numbers inside the square root, and 143 is greater than 140. Well, the 24 plus square root of 143 is the b squared, and the 24 plus square root of 140 is the a squared. So we can conclude that b squared is greater than a squared. Since a and b are both positive numbers, b squared greater than a squared implies that b is greater than a. This essentially means that if the square of one number is greater, then the original number must also be greater too. Since b is greater than a, if we look at the original values we set for a and b, we can conclude that square root of 11 plus square root of 13 is greater than square root of 10 plus square root of 14. So this means the second expression, square root of 11 plus square root of 13, is the greater of the two expressions. So this method of squaring both expressions is a fairly common technique when comparing square root expressions. In this case, it worked out very nicely since the sum of the numbers inside the square roots for both expressions were the same, since 10 plus 14 and 11 plus 13 both equal 24. This would ensure that when we squared both expressions, the integer parts turned out to be equal. So how about this one? How do we compare the square root of 3 plus the square root of 5 with the square root of 15? Well, a good bet would be to square both expressions. So if we let a equal the square root of 3 plus the square root of 5, and b equal the square root of 15, then a squared is just equal to the square root of 3 plus the square root of 5, all squared, which is equal to 8 plus 2 square root of 15. And b squared would just equal to the square root of 15 all squared, and that just simplifies to 15. So now we're comparing 8 plus 2 square root of 15 with 15. So what we can do is subtract 8 from both expressions, and it would still be the same comparison. So if we do that, then we are now comparing 2 square root of 15 with 7. To determine which of the two expressions are greater, we can square both sides again. So now we're comparing 2 square root of 15 all squared with 7 squared, and that just simplifies to 60 compared to 49. So we can see that 60 is greater than 49. So this means 2 square root of 15 is greater than 7. So 7 corresponds to 15, and 2 square root of 15 corresponds to the 8 plus 2 square root of 15 in the comparison between a squared and b squared. And since 2 square root of 15 is the greater of the two expressions, we can conclude that 8 plus 2 square root of 15 is greater than 15. So this means a squared is greater than b squared, which implies a is greater than b. So if we look at the original values set for a and b, we can conclude that square root of 3 plus the square root of 5 is greater than the square root of 15. So the square root of 3 plus the square root of 5 is the greater of the two expressions. So how do we compare something like the square root of 7 minus the square root of 6 with the square root of 6 minus the square root of 5? What we can do is compare the reciprocals of both expressions. So if we let a equal the square root of 7 minus the square root of 6, and b equal the square root of 6 minus the square root of 5, then 1 over a is equal to 1 over square root of 7 minus the square root of 6, and 1 over b is equal to 1 over the square root of 6 minus the square root of 5. And what we'll do is we'll compare 1 over a with 1 over b instead. So if we rationalize the denominator for 1 over a, the expression becomes the square root of 7 plus the square root of 6 divided by the square root of 7 minus the square root of 6 times the square root of 7 plus the square root of 6. And that simplifies to the square root of 7 plus the square root of 6 over 7 minus 6. And this is just equal to the square root of 7 plus the square root of 6. And if we want to rationalize the denominator for 1 over b, the expression becomes square root of 6 plus the square root of 5 divided by the square root of 6 minus the square root of 5 times the square root of 6 plus the square root of 5. This simplifies to the square root of 6 plus the square root of 5 divided by 6 minus 5, and that just equals the square root of 6 plus the square root of 5. 1 over a and 1 over b both have a square root of 6 term, but the square root of 7 in 1 over a is greater than the square root of 5 in 1 over b. So we can clearly tell that 1 over a is greater than 1 over b. Since a and b are both positive, this means 1 over a greater than 1 over b implies that b is greater than a. This makes sense because in general, for fractions without any negative numerators or denominators, whenever we have two fractions with the same numerator, the one with the smaller denominator is greater. So with the values of a and b in mind, we can conclude that the square root of 6 minus the square root of 5 is greater than the square root of 7 minus the square root of 6. So we know that square root of 6 minus the square root of 5 is the greater of the two expressions. Whenever we are comparing expressions that are a difference of two square roots and the differences of the numbers inside the square roots are the same, we can instead compare their reciprocals and then rationalize the denominator, and things work out very nicely. So in this case, 7 and 6 from the first expression have a difference of 1, and so do 6 and 5 from the second expression.